Hi, I'm Justin Snedden from the AR team at Niantic, and today I'm going to walk you through using our semantics system. What we'll do is we'll build a very simple demo that allows you to click on the screen and determine what's in that pixel. So what semantics do is they interpret the real world to work out whether something is ground or the sky or buildings, trees. There are a few other categories we can do, and we'll build a very, very simple demo that just walks through all of those things. So go ahead and set up, if you haven't already, set up a scene that works. So you've imported the ARDK, you've pulled in the examples, because I'm just going to use some of the bits and pieces from there. You don't have to pull examples, to be honest. You can use cubes if you'd like to follow on that way in the demo. Once you've got this running, make sure it works on the phone and that you've set everything up. So I'm assuming that everything runs for you. In actual fact, I've just reopened the same tutorial from the previous depth example where we were doing occlusions. So you can see here's our Captain Dotty before, and I'm just going to make a new scene in here. You can do the same if you'd like. It does save some time. Let's make a new folder, call it Semantics, and in here we'll make a new scene. And we'll also call that Semantics. Right, so let's open that up. Empty scene again. So very similar theme with all of these tutorials is that we start by adding in the managers that we need to use in order to build the AR system. So in this case we want semantics, so there's a semantic segmentation manager. We will also still need the AR session manager in order to run all of the AR features. We will need a camera position helper to make sure that the phone position is tracked against the world, and an AR rendering manager in order to draw everything. So again, I'm just going to plonk all of these things on the camera because it's easier for demonstration, but you do not have to put them there. You can make your hierarchy however you would like it for your particular game. So let's get going. We need an AR session manager. Then we need an AR camera position helper. And then we need a rendering manager. AR rendering manager. And then we need an AR semantic segmentation manager. So now we have everything in the scene. Quickly check that, as before, each of these that require it are pointing at the right camera. So for example, this script tends to not automatically detect the camera. So it's always worth a quick check just to make sure that wherever there's a camera required, it has been passed into your script correctly, because without that, nothing will work. The other thing we need to do with an AR camera is always set it to a solid color and make it black. This is because we remove backgrounds and replace it with camera feeds, so that helps us do that. So now we've got the basic setup done. Again, we have a script now that we can save and run, but it won't do anything because all we've said is we want to use these features. So you get our mock system kicks in and you can see nothing and nothing happens. So we need to do a few things. Firstly, we need to set up a script so that we can catch the semantic buffer in order to query it, and we also need to set up some simple mocking so that we can see what's going on the screen. So let's do the first thing of just making a script. So we'll come to our folder and go create script, and we can just call this semantics, or anything else you'd like to call it. It doesn't particularly matter. Let's open that script up, and I'll put the very basic things in to start with here for what we need to do, which is we want to grab the semantic manager, the camera. So we'll need to pass a few things in. So let's start with this. I'm just going to paste things in so you don't have to watch me slowly type. In here we are basically saying we will need the semantic buffer, whatever the latest one is, so we're just going to cache that. That's what the subject's for. We'll need that semantic manager that we just added because we want to ask it questions about what's in the scene, and we'll need to know the camera. So for these two we just pass in. This we'll catch from a callback. The callback that we're going to add is from the manager, from the semantic manager. So in the startup function we just say, hey semantic manager that we've passed in, can you, when you update, call this function for us, and we'll just write that function. So it's very simple. At the moment it won't do anything because it'll just be a blank function. In here you can catch the awareness buffer. So basically we said we needed to catch this. The way you do it is we've got this callback, the callback runs and it passes in some arguments. So just make this a bit bigger so you can see the whole line there. You've got this args object, which is passing in a bunch of stuff, and within that args we can say, hey, whatever the sender object for this was, so the system that's sending it, give me the awareness buffer. Awareness buffer is the general term we use for the different types that we can provide. So in this case, this will be of type isemantic segmentation buffer because we're catching a segmentation callback, but if we were catching a depth one, then this would be an depth buffer callback. So it's a general term here. But in any event, we now have this variable which contains the latest semantics buffer that you could use. Again, our system doesn't really do anything yet, but the next thing we should do is make something we can see in the scene. So let's set up our mocking system to have some objects. Just noted there's a couple of errors here. This is because I've once again forgot to put in namespaces. Apologies. Let's drop in a few namespaces to get rid of these warnings for you. It's essentially I haven't actually said we're using ARDK, which is a problem. So we need ARDK, we need utilities to be able to access some of the manager stuff, we need also extensions as part of the manager stuff, the args that we pass through, configuration for the system, and then in general we need to use the awareness functions because we want to use semantics. So you need all of those. As I mentioned before, there is a text version of all of these, so you can look through that as well. So if you can't quite keep up with what I'm doing, it's okay. You'll be able to read the actual code because it's quite a bit. Right, let's come back into here. Hopefully this gets rid of all of these errors. There we go. Great. Now, what we were saying is we want to put in some mocking objects. So last time we dropped in the mock-up scene, which we could do here too, or you could just add some cubes. Like essentially any object can be a mocking object, so I'm just going to go, hey, here's a cube, and I'm going to say that for this cube, I want it to be a particular type of semantic. When you click on it, first of all, let's put it to the mock world layer because we don't want it in the real world, but it's a pretend object. If you don't have that layer, as in the last tutorial, just go add layer and add ARDK mock world and it will work. So let's go back to my cube, ensure that your cube is on that. Then what we can add to this is a script for the mocking system to tell it what type of semantic this should be. Sorry, can't type, mock. You see this is mock semantic label. So if we add one of these, we can actually say to the system, any one of our available channels is what this cube is going to be. So we'll just say sky is okay for that, and if we want, we can drop a material on it so that it's nice and easy to see. I'll make it blue because skies are blue, and then let's quickly duplicate this object so that we have more than one. So Command D, cube 2, and we'll change this one from sky. We'll make it ground. And instead of being blue, I will make it green. There we go. So now let's move it over a bit so we can see the two of them. So in our scene, we don't have anything great in here, but we do have these two boxes. This is a sky pixel, and this is a ground pixel, or pixels, sorry, it'll be quite large on screen. If we click on our camera, you got these two dots. Now, the next thing that we need to do here is make a little click system. So if I in the game click on either of these, I can say what is this when I click on it. So update our script a little bit more. Let's go back to code. Now what we'll do in here is say that we need a touch event, and so that's the sort of standard code stuff. So let's just go down to our update loop. So hey, when you touch the screen or you click the mouse, we want to do something. So what we can do here is put some debugging code in, just to save us making UI objects for now. So when you touch the screen, we're going to write a bit of debug, and the way that you access information from the semantics manager is within it there's this other object called semantics buffer processor, and it has a number of functions and a number of variables that you can query that will help you determine what's in the actual buffer that's been returned. So essentially what semantics returns is for every single pixel on the screen, it has a guess at what's in that pixel. So it may be one or more channels, or it may be nothing at all. So the first thing that we're writing here is when you click the screen, just tell me in general, how many channels do we have, and what are the names of all those channels. So all this is literally going to do is print out for the ML model that's running in the background what does it actually know about. So it'll write things like sky, ground, grass, trees, water. Not very useful for anything, but it's handy for debugging, just in case you're like, oh, I set something to grass and it doesn't work at all. And if the model doesn't return grass, that's why. So the next thing we can do is grab the XY position that we've clicked. So as this is in an on touch, we can actually say, hey touch, what screen position is that? And then from that, we can actually start using some functions that query the buffer processor for coordinates on the screen. So in here, we can say, give me the indices of the channels. So instead of the strings, it'll give you 0, 1, 2, 3, 4, 5. So 0 for sky, 1 for ground, into a list of ints that you could use. And we can write those out as well. So we can do a quick debug loop of those. And so for each one of these, write out what it was. And then that's not so useful. We probably want to use strings. Luckily enough, we do also provide the string version. These are all for optimizations. It really comes down to what you're writing. Obviously, checking an int versus an int is quicker than checking a string versus a string, but it depends on what your game is doing and how much this matters in terms of performance. You're probably just going to use the string functions. That's what I would recommend you do. They look exactly the same, just the difference here is this is an array of strings. So what this function says is, hey Semantic Manager, I just clicked on this point. Is there anything there? Can you tell me what it is? So it'll give you the names at that location, drops it into an array, and then you print them out. The reason why it's an array and not a singular value is any particular pixel can have more than one semantic response. So if you think about the ground, it can be grass, it can be dirt, it could be pavement, and a combination of all of those things. So the system allows any pixel to have multiple representations of what it is. And that allows us to also extend the system later. So as we add more things, we can be even more specific about the type of ground that is. And you'll have more and more available to you as a developer to use. So what we've written here is very, very simple. When you click the screen at any point, it'll give you a list of everything that's possible, and then it'll say what it thinks you clicked on. So let's save this, go back to our editor, and run. Right, one moment while it thinks. Hopefully we're all fine. Yep. Now, I wrote all of those just to print to the console, so hopefully when I click, just one moment, please. Working. The reason this isn't working is because I've got to do something quite important, which is actually use our script. So if we go back to here, Semantics, and I made this script, but I didn't actually put it anywhere into the scene. So again, I'll just drop this on the camera because it makes it easier to find. We're not. It doesn't have to be here. You can put it wherever you'd like. And again, make sure these things are set. So our script, it required the Semantics manager, which is on the camera. So pass it in, and it also requires the camera itself, so pass that in. Now that we've got those things, we quickly save, and if we run this time, when we click, we'll actually get some output because our script is now running. So again, we go to the console. If I click, so it comes in and it's just writing a bunch of things. It says, hey, there's 7 channels available, and it's writing out what they are. When I click on a particular thing, you get the index and the name as we asked for. So if I click on the other one, you get the index and the name. So sky is 0 and ground is 1. And that's a very basic demo of getting these parts to work. What we'll do next is we'll build a bit more of a system where we have a little mini game that just says, hey character, can you go and find me a tree, or can you find me some water in the world, and then we'll wander around the world to find that object. First, in order to make that little game, is we probably don't want to be printing to the console anymore, so we'll just add a quick text box directly into the center of the screen. So if we just go UI text, and we've got this text box here, I'll quickly just don't rename it. I want to frame up on it, so just click over here. We've got this text box that doesn't do much, but let's just put welcome in it to the starting message. It's probably going to be a bit small, so I'll just quickly run just to see what this looks like. So it's tiny text. That won't be helpful to us, so let's make this a lot bigger. So instead of 14, maybe 64 might be a reasonable size for this. Okay, sorry. you're now seeing my lack of Unity skills live. So this is not big enough. I don't know, 1,000. Yeah, very big. So now we've got some text that we can read. Feel free to make it even bigger or however you'd like it to be. I will also set the vertical to overflow, so we can just put a lot of text in it and it'll always stay on the screen. I might even quickly change the text color if I remember where that is. Here we go. So instead of being black, let's make this no, brighter. Maybe I'll go for purple. There we go. Purple writing. Feel free to choose the color of choice, and hopefully that makes it slightly easier to read. I am also just going to make this bigger, so 96, because I'm finding that hard to read. There you go. Welcome. Now, all we need to do is pass this into our script. So, you know, this is the very standard. The very standard Unity stuff. We just basically say, hey, I want to use text, so we need to add in a text object. Make that public so we can pass it in. To use that, we will need the Unity engine.ui namespace. Alright, just come back over here, make sure it's compiling correctly, which that's happy, and then go to our script and just pass in this object so that we've got it. So we don't forget, just select this and change it to the text. Save that, and now what we can do is for all of those printouts that we were doing before, we can just push them into this text box. So let's quickly do that before we start writing new code. So where I had all of these debug.logs, let's just make those text.text equals. We won't write this out anymore because it's not really needed, so I'm just going to comment that out for now. Otherwise we'd get a big list every time we click anything, and we probably don't want to use the index version, so we won't use that either. But this is quite useful, so let's start with this. Instead of debug.log, we will just say called underscore text. I don't know why it auto-completed the test, but it did. There we go, and we'll save that, and all we'll get now is that the same messages we were getting before will be written on the screen. It's a little bit nicer. So that's the sky, and that's a ground. That's a sky, that's a ground. Now at this point, you kind of know how semantics works for the very basics, which is, hey, I want to query a pixel and find out what's in it. You can also check that it's returning nothing and say that's nothing, which is probably useful, so it's sky and ground. But in theory, if there are other things in the scene, they would also detect. So just to make that point, if I make another cube, I'll just find this one. If I Command D this and duplicate it out, and I was to say this is a different channel, so this is, let's say this one's foliage, because it's also green. Let's move that up and over so we can see it. And then if I run this, I'll get a third value found. So sky, ground, foliage. And essentially, you could just make as many of these cubes as you want, and that really is the end of this demo. If you want to make it slightly more fancy, we can write a little bit of script that loops to make a game, as I mentioned before, which is what I have in the text version of this. What I'm going to do is basically say, the first thing you probably want to do is make a little level in here out of your cubes and boxes. So you could either import a nice little environment that you have built before, or you can simply make a couple of simple cube-based systems. So for example, I'm going to very quickly now, probably in a fast-forward mode when I edit this, make a few trees, a ground plane, and some water, just to make this into something that looks nice. Alright, so I've quickly built this little scene here in either accelerated mode or a hard cut. I'm not sure what I'm going to do, but here we go. So I've built this scene, made some really quick and dirty trees. I've set this as water, I've set this as ground, and I've set that as sky. So what you have here is effectively a mini park. So the next thing we're going to do is jump back into code, and we're going to change a lot of this function to be a bit of a game. So here we go. The first thing we're going to want is to add a few things. So let's say the game we were designing is about finding things. So we first need to say, well, what are we going to find? In our scene, we have some grass, we have some water, and we have some foliage. We also have some sky. We could add that in there too. But basically, I'm going to write a function that says randomly pick one of these things, and then say, you know what? Go and find me that thing. We'll also need a few variables for that to work. So let's add those in. Firstly, we will have a timer for how long we want that thing to be found for. So go and find me foliage within the next 3 seconds. Run around and find it. Something to say before we ask you to find something else again, wait a little bit of time. We probably want to score in our game, so end the game after you find 5 things, and then here what is the actual thing we're looking for at the moment. So when the random function goes off and it picks grass, we'll store it in here, and then a bool to say whether we were successfully finding that thing in the time frame or not. The function for finding something, we're just going to use Unity's random. It's not very hard, so just make this pick a random thing to find. It just picks a random in range. It looks at that in that list of items that we just made and picks one of them. And then it also gives you a random amount of time to go and find that thing. So between 5 and 10 seconds to find a piece of water. It resets this to say that you haven't found anything because it's the first time that you are going through this loop. Now, in the update, we're going to need a few bits and bobs. So for starters, we will say when we start our game, have we won it yet? So the condition to say end is the first thing we need. So as I said before, if you find 5 things, we've got a quest reward of our lovely +2 Vorpal shoulder pads. The next thing we'll need to do is for those timers that we made, we need to tick them down. So as the quest is running, tick down the amount of time left to find things. If you are waiting for something, tick down the amount of time you're waiting for something. Then the next thing is looking at, if the wait timer is active, then don't continue because we're waiting. We don't want the game logic to keep playing. And after that, we basically are saying, hey, let's check our find condition to see if we found the thing in enough time or not. It's going to be a bit complex, so I'm just going to plonk in quite a bit of code and then talk through it. Did we find it? So yes or no. It's fairly straightforward. If we didn't find it, well, we failed this quest. And we set this wait timer to say, hey, just put a message up saying you failed for a few seconds. And then continue. If you did find it, so this doesn't run, we just pick another item and say, hey, yeah, that was great, thank you for that, and can you find me something else? So it's literally just going to keep asking you to find things constantly. Just for simplicity, I am going to quickly paste in the rest of this and then talk through it, because this is not the easiest way to do this. Alright, so next we do our input functions that we had before, same as we did before, like get the touch. If someone's touched, get the position that they're touched at. It's the same code we had before. Now we're going to use a function we didn't use in the short version, which is does channel exist at XY, and pass in the name of the channel. So the difference between this function and the one we were using before is this specifically says, is this channel that we're looking for there, rather than tell me everything that's in that pixel. You could have used the other function to return a list and then compare the list to see if it matches the item that you were looking for. This function does that for you, so you can just use that instead. So from the processor, call it, pass in the XY position, and say, hey, they clicked here. Did it have a tree in it, or whatever it was we were looking for? And if it did, then go, yeah, great, you found it. Thank you very much. Reset the find timer, put the wait timer in to say, wait a bit before giving me another quest, increment my score, and then say, yep, I found it this time, so that when we come back around up here, it knows what message to put out. If it doesn't exist, so the thing you're looking for isn't what they clicked on, we want a message that says, that's not what we were looking for, I'm sorry, mate. So in here, we use the function we had before to get what did they click on, and we go, well, what's in that pixel? Check if there was anything in the pixel. So if there was something in there, I'm just taking the very first item, because there could be more than one, but the first one will do for the error message. So it's that you clicked on the sky, or you clicked on the ground. The ground may have shown up as ground artificial, a couple of other things, but it would just say the first one. And if there's nothing in there, so if they've clicked on an area of the screen that doesn't have a semantic label, you just say it didn't find anything, so I'll just put thin air. And then we make a little error message here that says, no, that's not what I was looking for. You found sky, I was after grass. And now we have our whole game, really. It's very, very, very simple. So if I scroll back up, it literally just says, ask the user to find 5 randomized things from here, and keep going until they get the 5 done. When they get the 5 done, pop up a little win message. So if I now save this, go back to the editor, I've probably got a couple of typos in here. I've just stuffed up, because I did that paste of the number of brackets that I need, so I'll just quickly count. Hang on. That's fine. That's one missing, I think. Yep, there we go. Now if I run this, we get welcome, and then we get our message saying, hey there, adventurer, could you find me some foliage? If you click on foliage, it goes, yeah, great, thank you very much, you got me some of that. But I also like some water. Go and find me some water. Oh no, I didn't get there quick enough. Find me some grass. I clicked on the wrong thing, that wasn't grass. And there you go, there's a very small game. One thing to note, see how I've clicked on the grass and it's saying it's not grass. The reason this isn't working is I just didn't add it to the layer when I was making this environment. So always make sure that you set whatever geometry that you add in here into your mock world to be part of the mocking system, or otherwise when you click on it, it's not going to work. So let's set all of those. There we go. And if I rerun the little mini game, welcome. Hi, please find me some foliage. So click on the tree. That's exactly what I was looking for. We want some more foliage. There we go. Could you find me some grass? Oh, that's not grass, that's ground. So I'll probably never be able to get grass because I've not set anything to grass. So maybe I'll change that shortly, and hopefully it'll ask me for something other than grass in a minute. Actually, I can just click on it, so you see that sky's working now, and the water will as well. So very quickly, let's make a few more edits, and then we're done. So I've got all these things just plonked in the root here, so I will create an empty at just zero it out, and I will put all of these things into this. You could rename these to have nicer names so that we know what they are, but I'm not going to bother right now. Just call it that just so they know what it is, and then I'll just do the same trick here, which is that way I never forget, because everything under here is in the mock world layer. With that done, we probably want to move it back a little bit too, because as you saw when it started, we were inside an object. And the last thing I wanted to change was, because I set this to ground, and in the game I wrote grass, so I'll just set that to grass. And away we go. Should probably move it down a little bit too, but anyway, here we go. We've got our little system. Hi, please find me some foliage. There you go. Hi, find me some grass. There you go. Great. Find me some more foliage. And some more foliage. Grass. Oh, likes his trees. And there you go. And then we get the wind condition. Yay! I get my shoulder pads, and I can go on a raid somewhere. Excellent. So that is basically everything you need to do, and it was all done in the editor, it's super nice to be able to do that. The thing that is brilliant about this is it's just going to work when we run this on the phone. It'll remove this test geometry that we built the game with, and you'll have to run around like crazy to try and find the things that it's asking you to find. So I'll just build it and prove that it works by showing you it on device. But in general, being able to work in the mocking system like this saves so much time. Because as you can see, every time I press build, it takes a couple of minutes for that to do what it needs to do, like go through the Xcode loop of building the application and running. So you lose sort of 2 minutes every time you were doing that before. Whereas with ARDK, you can build most of your game directly in the editor, or at least some of the features you're trying to build in your game directly in the editor, test that they work, and then move to the phone when you're doing the final tweaking, rather than having to do all of it in that phone loop. And here we go, Xcode doing its thing. Okay, so it took a while, but it is running on my phone. Just passing this through. So it's running. The mock world is there because I forgot to turn it off on the camera layer. But as you can see, I don't have any water in my or foliage in my house, so I can't run that. Just give me 2 seconds and we'll get this to work properly. So in here, what I forgot to do was click on the camera and make sure that we don't want to pass that through. So you can see already in the preview that it wasn't going to work because it was drawing that here, and in the real camera it shouldn't see the mock world because it should only ever exist in the Unity space. So let's save that again. I am going to quickly change a few things just so that it will work in my house. So if I come back to oh, this is completely the wrong example. We want to look at this one. So in here, what we've written was that please go and find me a grass. I'm just going to change this to say ground, because that is something that I have in my room. If I switch that, come back in here, and then we click on here, and we make this ground again, and then we build it. Well, we should just quickly check in editor that I haven't broken anything. That's always good to do because it's quick. Welcome. Can you find me some foliage? Yes, I can. That's what he was looking for. Can you find me some water? Yes, I can. And ground. Great. So ground is doing what I wanted it to do. And now if we build this to phone again, another 2-minute wait, sorry, we will be able to run this in my room, and hopefully when it asks me for some ground and I click on the ground, it will all just work. Okay, so now that'll run on device, so just launching it on my phone, so it's on my desk at the moment, so I'll just move it over here so it actually works, and there you go. Now that so it is working, but as you saw there, we have a bug to do with the casing. So you can see capitalized letter is causing a problem on the phone. This is a small bug. It should be fixed by the time you guys start using ARDK. But for completion, I just add a little bit of code now to show you how to fix that, which is just put an if statement in. Use the hashtag unity define. If you're in the editor, you want to use the capital G ground, and if you're on device, you want to use lower G ground. We'll just do that now. Alright, so we go back to our code, and this is the code you need here. It's just, when we're in the editor, it was looking for capital G, and when we are on the device, it's looking for lowercase g. As I said, this will hopefully be fixed by the time you are using ARDK. It's just I am working with a beta version in order to make this demo for you. So if I once again run this in editor, it should work, and then when I run it on device, it should also work. So here we are in the editor. Let's move over here. Yeah, there's after foliage. Let's wait for it to actually ask me for ground or foliage. It doesn't really matter. It's just the casing. Find me some foliage, and yes, it works in the editor. That's what I was looking for. Build it again. So Control B. at least this gives you an idea of what I was talking about with the development loop. As you can see, it takes quite a while to do this, and the fact that we got it all working in semantics is great. The thing I'm actually debugging now is hopefully something you don't hit, because it's actually a bug in our code base, not a problem with the way that we would work here. There we go. Let's bring in the monitor. Launching. Hi, find me some water. No, that's ground. I needed water. As you can see, it's changed the case of ground. So hopefully when we find one that asks me for ground, it'll work. Find me some ground. That looks like ground. Yay, there we go. So now it's working. And that is the end of this demo. Sorry for all of the back and forth here to get it to actually work on the phone, but hopefully you don't run into those bugs. But it was worth walking through it just so you could see how that all works. So hopefully have a good day and enjoy playing with ARDK.